Welcome to this third session on the theories of consciousness, where we will go through and describe the global neuronal workspace theory, or global workspace framework for describing consciousness. And as all of these theories discussed here, the global neuronal workspace, or GNW for short, wants to explain what is the difference between a conscious mental state and an unconscious mental state. And here, the global neuronal workspace describes consciousness as a form of information processing, where sensory data come in and go into a global workspace, which then can be distributed to distribute this information to other brain areas, other brain centers. Now, the first thing to mention here is actually that the global neuronal workspace is a very popular theory of consciousness. And to give you an idea, we want to share this recent study that looked at 412 studies, empirical studies on consciousness. So these are research papers. And they looked at whether an experimental study interpreted their experiment as supporting one of these four theories that we're dealing with here. So as you remember, we went through first order theories and recurrent processing theory, and we've gone through higher order fault theory. Then there's also integrated information theory, or IIT, which we will deal with in the last session. And now we're dealing with global neuronal workspace. And as you can see here, when these researchers count up how much do an experimental study interpret their experiments as supporting one of these hypotheses, the global neuronal workspace theory pulls out ahead in front of the other theories. And this is a trend that has been increasing over the past year. So global neuronal workspace theory is a very popular theory. So, of course, if you really want to understand the research of consciousness, you need to understand all of the theories. But you could say that because global neuronal workspace theory is so important right now, if you were to end up in a research group interested in consciousness, the chances are that you should know what global neuronal workspace is. Now, the point about global workspace theory is that it's built around the specific prediction that for a mental state to be conscious, then the brain activity associated with that mental state needs to be widely distributed in the brain, in a global network of the brain. So opposed to brain activity being local. So for example, if brain activity is in a small region of the brain, let's say the visual cortex, and it will be only those areas like V1, V2, and V3, and so on, that would be a local area. Whereas if it was global and widely distributed, it would go to many other different lobes in the visual cortex or occipital cortex. It would go to, for example, the parietal cortex and frontal cortex, in order to become this broad signal that becomes conscious, according to the global neuronal workspace theory. So it is seen as a form of information processing that occurs and is then distributed globally. So it is, for global neuronal workspace, consciousness is just a type or a kind of information processing. And as sensory data come in, they enter into this global workspace and is then able to be distributed to other brain centers. And when it does so, it becomes conscious. The information becomes conscious. The global workspace theory is heavily influenced thus by information processing theory, which in short likes to compare the brain to a computer and ask if information can be processed in this way, as if the brain is just a biological machine. In short, information processing theories sees the mind similar to a computer. And most have probably heard about working memory as a type of information processing, which is a cognitive system where you hold limited information temporarily. It could be incoming sensory data, or you can think about some stored memory. So the idea of a global workspace has evolved from the concept of working memory. And it's easy to see how the global neuronal workspace has evolved from the concept of working memory, and how that global workspace then relates to consciousness. Because when you think of it, everything you hold in working memory is conscious. So when you recite, for example, a phone number, as you go through it, you will pull that into working memory. So that's even if you have this phone number remembered automatically and you sort of can go through each number, as you do so, you pull it into working memory. So let's say I go through this phone number here, 88, and then 85, and then 55. What I'm doing is I'm going through each, and as I get to 55, we can look at it and say that it gets into this global workspace or this working memory, and as global neuronal workspace would say, it enters onto the theater of consciousness. It becomes conscious as I'm holding it in working memory. And then when I say 55, I am taking that global workspace, and as I hold it in working memory, it becomes available for verbal report. So I can verbally report 55 because I'm currently holding it in working memory. And this is the point that global neuronal workspace makes, is that when we become conscious of something, we make that information available globally to a range of different mental processes. And that could be verbal report, but it could also be, for example, reasoning. So for example, I could say 55 plus 1 is 65, or I could say it could be recollection. So I could recall that I drank 55 cups of coffee yesterday, or I could plan to, or I will drink 55 cups of coffee today. So what is meant here is that I can do different things with this. Conscious information can be manipulated. And so this is Bernard Baers, who proposed the global workspace theory. And this is a core part of global workspace, that when information becomes conscious, it is made available, or you can broadcast it globally to many different mental processes. So here we see that sensory input comes in, vision, hearing, touch, and so on. And as it comes in, it becomes conscious. As it comes into working memory storage, you can use your executive functions to sort of voluntary, in a top-down attention way, attend to these incoming sensory streams. And as you do, they become conscious. When you do, it opens up to different mental processes like action and planning, which leads to responses. But it could also be that what you sense doesn't lead to action, but leads to sort of learning, or to storing some information. Or information could be pulled from from long-term memory to short-term memory, and then that would mean that you become conscious of it, and it could lead to some action. Yeah. So one analogy that I like to use is that for global neuronal workspace, consciousness is similar to a small key which can open up a large unconscious door. So the idea here is that most of what goes on is handled automatically in the brain and in our minds. So what we do is most of it is unconscious. So for example, I'm speaking right now, I'm not focusing on how I'm breathing, even though I'm doing it. I'm not focusing on the grammatical structure of what I'm saying. I'm just focusing on the word I'm about to say, and I don't know which word will be at the end of the sentence. A lot of our actions are automatic, like we drive home and we completely zone out, and this automatic pilot just takes over before you are home. And therein lies the realization that a massive amount of information processing in the brain is unconscious. And a lot of it is distributed in vastly different functions. So for global neuronal workspace, consciousness is this very limited conscious spotlight, which we saw, which is this theater metaphor, that you shine a spotlight on a stage on a certain type of information, and then that information opens up. Once we focus on this mental process or specific information that we hold in working memory, it opens up this large unconscious door to all of those functions related to that mental process or mental content. So we open up to intentions and memories and perceptions, self-reference memory, expectations. Everything that that mental state can do is opened up. So one way that has shaped the global neuronal workspace is how researchers who were proponents of the theory ask certain questions about information processing, specifically the difference between unconscious processing and conscious processing. How is information processed consciously versus unconsciously? And specifically, the global workspace became the global neuronal workspace because of differences in brain activity when subjects consciously process stimuli versus when they consciously process stimuli. So to explain this, I'm going to break tradition a little bit and give an empirical study by the French neuroscientist Stanislas Dehaene, who has sort of championed the global workspace into the empirical domain. So in the study by Dehaene and his colleagues, what they did was they presented words very quickly to participants. And these words were numbers, which were spelled out in letters. And crucially, they were presented so fast, the participants can't report what they saw. This is what is termed the masked stimuli, which have these jumbled letters, which are presented before and after. And then you have here a 9 is presented. And so it's very hard to see this 9. And then afterwards, a number is presented, and the participant is simply told to say if this later number is smaller than 5 or larger than 5. And what happens is you measure how fast they are to react to this. And it actually shows that when this number here, 9, which is not a number, but spelled out in letters, when this is here, participants are faster because this is a congruent. The 9 is also above 5 and 6 is above 5. So it is a congruent trial. And their participants are actually faster, even though they don't say that they see this, even though they don't consciously perceive this 9, it still assists them in processing this number afterwards faster. And this, of course, has to be compared to the other example, which is when this it's 1 here. So this is an incongruent trial where this is lower than this number here. And there the response time, the reaction time is higher. So it's slower. And this shows you that there must be some sort of unconscious processing going on here with this letter 9 that is associated with the concept of 9, the number 9, which is influencing the subsequent perception and categorization of 6 to be larger than 5. And this is very, very interesting, and it reveals something in the brain that the brain processes this type of information unconsciously. And something else that they found was that already when this is being presented, this 9, there is a preparation in the motor cortex to already press this. So in this case, they're to press the left side, and if it's larger than 5, they press the right side. And already as this 9 is being processed, they are preparing in the motor cortex to do this. So what this shows is that the brain, this shows that there's a processing of unconscious stimuli that reaches motor preparation. And so unconscious stimuli is actually processed in the same route as conscious stimuli. So you can imagine if participants actually saw this 9 and were to react to it, there would equally be a preparation in motor cortex to press the left and right button. So unconsciously, they are doing the same thing. And this raises this fundamental question: why do we need consciousness if we can process stimuli unconsciously? And so what distinguishes conscious and unconscious processing? And this is where I'm going to quickly summarize the findings of Sergent and Dehane in their review from 2004, and say that while non-conscious and unconscious processing may activate the same areas of the brain, a lot of different additional areas also become active when the stimuli is consciously processed. And this is, again, the appeal to global neuronal workspace to say that conscious stimuli is broadcasted to a large global network. And there's also found that there's more connectivity or connectedness between these regions, and there's sort of co-activation of different areas at the same time. And additionally, these areas, these additional areas tend to be active at a sort of later time point in the processing. And it is also often implicated, this type of activity, conscious activity, as opposed to unconscious, often implicates these frontal-parietal regions. So there's these areas that become active during non-conscious processing and conscious processing. While they are the same sometimes, they become more active when they're consciously processed. So it's important not just to know that an area becomes active, but how much so does it become active? And it's generally larger. And this is also sometimes called ignition, that there's an ignition of the global workspace. Yeah, so in sum, the global neuronal workspace theory is a very popular theory, which explains conscious mental states as information processing, which exists in our workspace, similar to working memory, which is made available globally to a broad range of mental processes. So although a vast amount of information processing in the brain is processed unconsciously, consciousness in accordance with the global neuronal workspace is like the small key which can open the large door of the unconscious. So what is being held in working memory can be shined, that there is a spotlight that can be shined upon it, and it can be put on the center stage of the theater. And when it does so, it allows it to be manipulated by all kinds of processes, like, for example, verbal report or recollection. And lastly, global neuronal workspace is born out of the finding that unconscious and conscious processing activate the same areas of the brain, but conscious processing involve broader areas, more areas that are more connected and more active, and with a particular focus on the frontal parietal regions. All right, so that was global neuronal workspace. Thank you.